All right, welcome back. And in today's lecture, we'll talk about conceptual and intelligence development. Now, since this kind of expands like two major chapters, I am just gonna pick out like the most central stuff that I think that you should know. Okay. Now, what are concepts? Well, concepts are general ideas or understandings that can be used to group things together, basically. And having conceptual understanding of the world can really help us understand how the world works. And it can also help us by generalizing from prior experiences. Now, when you kind of think about the theme in development, there are several things when it comes to conceptual development. So the first one is nature versus nurture. The children's concept reflect the interaction between their specific experiences and their biological predispositions to process information in particular ways. Okay, so this is one of the most major one. The next one is the active child. Okay, so many children, their concept reflect their active attempts to make sense of the world. Okay, and the third major theme is how changes occur. So the researchers actually have really studied conceptual development. They really try to attempt to understand not only what concept children form, but also the processes by which how they form the conceptual development. Okay, now the fourth one is the socio-cultural context. So how does the culture or the society that we live in can actually influence the way that we form concepts? Now let's kind of briefly talk about how we understand the world around us. Basically, we have something called the category hierarchies. And so that is the category that is organized by set and subset relations, such as animals, dog, poodle, and blah, 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 stuff like that. So it has several levels. You can see that the most general levels, basically, you have something like uh, animals, okay, up here. And then you can see that how that is distinctly different from people. Now within animals, you can have it something more generalized, such as mammals or reptiles. They have something very distinctly different from them, right? And within mammals, you can subdivide them into something like the felines, the canines, the rodents, and even within the canines, then you can get into a very specific level, and that is something like cats, tigers, cheetahs, and stuff like that. And the same thing with people, you can do something like, let's say, Asians versus Europeans versus Americans, something like that. And within Asians, you can kind of categorize with something like Chinese, Korean, Japanese, blah, 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 and then when you kind of say that within the Chinese people, then you can say that these are the very famous, but very specific entities, like say Jackie Chan, Gong Li, Fan Bingbing, and people like that. So you can see that the level goes from the very general to less general to medium to specific. Now let's talk about infants' way of categorizing things. Okay, now infants, they are pretty good at categorizing things even at 3 to 4 months old. Okay, and so what they did is in this research, they show a series of photographs of very different breeds of cats. And then what happened is that the infants develop habituation to these cats. So which means that they will look at the new cat photographs for less and less amount of time. But then what happened is that if the infants were show a picture of a dog or like another animal, they dishabituated. So which means that they look at them more. So they were able to see that this is a different category from cats, rather, right? So that means that the habituation to the cat photograph suggests that the infant saw all the cats despite their differences as member of the single category. And then what happened is that later on, when they become dishabituated to the photographs of the dogs or other kind of animals, kind of suggested that the infants saw these creatures as members of the category of that's different from cats. Okay, so what happens is that at this age, infants often use perceptual categorization, which kind of groups things that look alike together. And then they usually do these categorization based on things like color, shape, size, and movement. Movement meaning like when things move together in the same direction, then the infants tend to group them together. Okay, I know not only infants do that, a lot of people do that also. Okay, so then what happened is that they are more likely to focus on specific parts of the object rather than the whole. For instance, infants before they're 18 months of age, they would tend to see that everything that has four legs that moves is an animal. Okay, but then they might not see things such as eight legs, such as spider, as animal because this violates their rules of having four legs. Okay, or if and things like that. Okay, so you'll see that they focus more like part of the object rather than the whole thing. Now, as children move beyond infancy, they start to really understand not only the individual categories, but also the hierarchical and cross relations among categories. And your book says the category hierarchies of young children usually kind of often include three levels. And then so there is a very general one, which is the superordinate level. And the very specific ones, that is a subordinate level, and the between ones, these are the basic level. Now, the children, when they are learning stuff, they usually learn the very basic level first. So you don't want to think about basic meaning very specific, okay, or very general. So the basic ones is actually in the middle. And so, for instance, they will learn tree first, okay, and then they will learn that they belong to the superordinate of plants because plants are more general than trees, right? And then they can also get to the very specific part of that. And like say, for instance, pine trees, apple trees, oak trees, and stuff like that. And now the children, they're not very good at learning all these basic categories compared to adults. So your book gives an example that when they are kind of forming the category of cars, motorcycle, or buses, the young children seem to group these objects together into a category of objects with wheels and with the object that moves. So they would think things like, they might think cars very similar to things like motorcycles. Okay, so they would not get to like the very specific categories like Toyotas versus Honda versus BMW versus Mercedes and stuff like that. Okay, now let's talk about the knowledge of other people and oneself. And this is the concept of naive psychology, which is the common sense level of understanding other people and oneself. And there are three concepts that we all use to understand behavior of other people and oneself, and that is trying to understand other people's desires, their beliefs, and actions. Now, one thing I want to bring out is that these two things, the desires and beliefs, are not observable. Okay, only action is observable, but desire and belief is not observable, which means what? Which means that you have to infer based on what people's actions and then think about what kind of desires and belief they must have in order to drive this kind of action that they took. Okay, so if they said something, what people are usually trying to do is they are trying to understand what desires they had and what kind of beliefs they have around the subject that they, which is which is the reason why it led to them saying this kind of stuff, okay, or did some kind of action. Now, the thing about naive psychology is that there are three main properties, and that is the first one is it's an invisible mental state. This is something that I talked about desire and beliefs that are not visible, and then therefore you need to use a lot of inferences to really understand what other people based on their actions. Okay, of course you can talk it out, but then do you always believe what they're saying? Okay, not all the time, right? So sometimes actions do speak louder than words, because words you can really kind of hide your intention and stuff like that. Okay, so the second property is it's linked to one another through a cause and effect relations. Okay, so which means that these things that are kind of related is that so these kind of things are kind of related based on there is a reason for someone to do something, and then the cause for that is the actual belief within a person, what a desire within a person, and this is what led them to have taken some sort of action or said something. Okay, and the third property of this, the way that we understand ourselves, is really that they really develop very early in life. So the infants, they were like young children. They really start to find people very interesting, and they're very careful. They pay careful attention to them, and then there are they really learn an impressive amount of them in the first year. So now, even very young children, they really prefer to look at people's face rather than like other objects. So you can see that the way that even infants start to develop this social bond with other people is something that's developed very early in life. Now let's talk about theory of mind, which is kind of like a packaged form of naive psychology. What you saw is a organized understanding of how mental processes such as intentions, desires, beliefs, perception, and emotions influence behavior. And this starts to come out like at the end of the first year in an infant. And your book talks about something that they tested a 12 months old, they saw an experiment to look at one of the two stuffed kittens, like stuffed animals, and say that, oh, look at this one, and then they really kind of preferred one of the stuffed animals, and then they put down the screen, and then it was after 2 seconds later, then the experimenter will hold one of the one that she has just really said that she thought that was cute with the one that she thought she did not praise on. Okay, then what happened is that when the if the experimenter is holding the one that she said that was cute, then the 12 months old did not pay that much more attention to it. But if the experimenter is holding the one that she did not say that it was cute, then this then the 12 months old toddler kind of is surprised and will look at this more longer, and is kind of suggesting that they're more surprised about this action. So which means that even at this age, the 12 months old, they can really use this information to kind of understanding the people's desire, which guide their actions. Okay, now the 8 months old, they cannot distinguish this. The 8 months old, they will look at both scenario around like equal amount of time. Okay, now the understanding that the desire really leads to action is firmly established by the end of the second year. Okay, now children at this age, they can really understand what people's connections between the people's desires and their actions, and not just acting out on their own preferences. So if you tell a story, if let's say you read a story about the Snow White and the seven dwarfs, and uh, to a child, and then you ask them, uh, you know, why things like, why do you think that the stepmother did this? Now they would not do it themselves, but then they understood the reason why, or the desire why the stepmother will want to get rid of Snow White. Okay, even though this is something that is completely out of character from most children. Okay. Okay, so the next thing I want to talk about is the false belief problems. All right, so the false belief problem is that the task that tests a child's understanding that other people will act in accord to their own beliefs, even when the child knows that these beliefs are incorrect. So basically, they try to kind of mismatch something, okay, and then they will use this mismatchment after that's been revealed to the child, and then they will ask the child, what do you think others would do in this case? Now, you might think that because they start to understand people's desires and actions by the second year, that they should be able to do this kind of false belief problems by the third year, but this is not true. They will only this starts to develop by the fifth year, okay, which is pretty late. Okay, and I'll tell you the example in the next slide. You'll see it. So this is what the task actually looks like. Typically, what they do is the experimenter is going to ask a child with a box of Smarties. All right, so if you don't know what Smarties are, this is actually a kind of candy. Okay, so they will ask them, what do you think is in the box? And then the child would, with the box that's closed, and then because the label outside says Smarties, and then of course the children are gonna say Smarties. Okay, and then then the experimenter say, why don't you open the box and see? And then they open it and see, oh, it's actually pencils. Okay, and then now the experimenter is gonna say, now let's close the box again. What do you think your friend Jenny would say if it's the box, if she saw it? And then now a 3-year-old would say that it's pencils. Okay, but 5-year-old would be able to kind of relate this false belief problem to their original idea that, because I saw this boxes that is out that on the outside without knowing the content that is being in the box, I thought there was Smarties. Okay, but the 5-year-olds, they were able to say that the Jenny will also think that it's Smarties inside. So you think that this kind of false belief problem kind of develops a little bit later until the children can start to reason. Now let's talk about understanding why, where, when, and how many. So understanding like the why really happens, really the major improvement happens from childhood to adolescence. And then, so this is the idea of understanding cause and effect, okay? And understanding how things work and how things, what are the mechanisms, why events occur. Okay, so the example you see children do a lot is they would tend to take toys apart and trying to understand how does a thing connect to another, and then why does it work. And a lot of boys do this, and some girls do this as well. Some girls were more likely to ask questions of adults and why things happen. So this is why girls tend to ask more questions, and then boys tend to kind of trying to figure it out themselves. And this is also one of the reasons why boys seem to make more trouble than girls. Okay, and but this is just something that is innately different from boys than girls. Okay, now let's talk about the causal reasoning in infancy. So we start to see some sign of this causal inference at 6 months old, and then and of course it only start to get better after that. By 9 months, their understanding really not only influence their expectations about the objects, but then also about their ability to remember or imitate, like the sequence of events to the outcome that these toddlers what the infants what they want. And then by age 2, the end of age 2, these children, they can really infer the causal impact of one variable based on indirectly relevant information about the other. Now, on the right, what you're seeing is that this is the toddler's problem solving in the task that's used by Chen and Ziegler. And they have this examine the toddler's causal reasoning and problem solving. And then so they have these toddler kind of choose the right tools for getting the toy turtle, require children to understand the importance of both the length of the shaft and the angle of the head relative to the shaft. Okay, so compared to younger toddlers, older toddlers have greater understanding of these causal relations, which led them to more often use tools rather than just reaching for the toy. Okay, and then so and more often choose like the right tools for the task. Okay, now let's talk about this ability during the preschool period. So this continues to grow during the preschool years. And you see that when the 4-year-old sees a potential cause to produce an effect inconsistently, they infer that something else is causing such inconsistency. Okay, now on the contrary, if they see something that produced the same effect over and over and over again, they would think that there is nothing else that is producing this effect. This is the sole variable. Okay, so you can see that even at 4-year-old, they start to get very good at causal reasoning during this period. And at 5-year-old, you'll see this ability becomes even a little bit more developed, because the reason is that their reaction to magic tricks. So you'll see that most 5-year-old, they start to find magic tricks fascinating because this kind of challenge our logic. But then their younger kids counterparts do not. So which means that 4-year-old, they don't find magic as fascinating because they could not make that much of a causal inference yet. Okay, now let's talk about space perception when it comes to development. Okay, now early in infancy, starting from the point that these infants can start move around, such as crawling or walking, then what happens, the perception of the objects really comes down to really two things that matters to the kids. How close is it to me and how far is it to me, okay? Now, so this is what Piaget actually terms this thing, the egocentric spatial representation. Okay, so that is basically the coding of the spatial location relative to one's own body with regards to the surroundings. Okay, and only when the toddlers start to develop and grow more, then they will learn to relate the location of the objects compared to other landmarks. Okay, now so the overall development goes from egocentric to a more landmark related as the children mature. And now let's talk about the next thing, and that is spatial reasoning. So spatial reasoning are things that you need to do. Now last time we talked about mental rotation, that's a spatial reasoning task, right? And well, puzzle solving is also another kind of spatial reasoning task. So in this spatial reasoning task, what they're doing is they show 4 figures that you see on the right, on the top right. Okay, so something that looks like arrows, right? And then they give they give the children like these 2 things on the bottom, and they ask them, okay, so when you combine these together, which of the top 4 figure can you make? And then the correct answer is of course this, right? And then so basically what the spatial reasoning is that's that. Okay, so but something I do want to add is that the children who play with puzzles more often between their 1st and 4th year, they have better chance of performing well on this kind of test, which means what? Which means that practice and also experiencing, having a more enriched experiencing really helps them to develop these kind of spatial reasoning ability early on in their life. Okay, but something I do want to add is that boys tend to be slightly better than girls on this kind of task, just for some reason. Actually for all of the spatial reasoning tasks, boys are slightly better than girls. Okay, I'm not saying all boys are better than all girls. Of course, there are a lot of overlap, but as a whole, boys are slightly better than girls on this task. Now let's talk about time development. So one thing that we know is that we really don't understand time perception that much. And people like from St. Augustine, from the 4th century, to Albert Einstein, who wrote about it in the 20th century, really have all talked about this mysterious nature of time. Okay, but your textbook kind of talked a little bit about what is the most basic sense of time perception, and that is temporal order, knowing what happens first and what happens next and what happens eventually. So you see that the passage of time really is a good way for us to understanding the causality of things, what happens first and this caused the second thing to happen, and so on. And you see that this ability for infants to start to understand what time is really start to emerge around 3 months of age. Okay, so for instance, they show the 3 months old a series of interesting photographs, and then first one on the left, and then another one on the right, and then another one on the left, and then so on. And then within 20 seconds, they begin to look at the side where there is no new photo to appear even before the photo was presented. So which means that they have this sense of expectations of something should be occurring at this place that is coming up. So which means that they are really expecting some sort of tempo, or some sort of tempo that really comes with it. Okay, and another thing that they really found is that in later stages of the infancy, they can discriminate between longer and shorter durations. So, for instance, the ratio of the durations rather than the differences in their absolute length is critical for noticing the differences. So, for instance, 6 months old, they're very good at knowing the ratio for 2 to 1, and at 1 month, but they're not able to discriminate 1.5 to 1 at 6 months old, but at 10 months old, they were able to do this pretty well. And now, when it comes to time reasoning, this really starts to become well developed at age of like 5 or so. So they can start to make logical inferences about time. And so they become quite good in when two events happens like simultaneously, and then they can start to see that these two events are most likely linked, or there is some sort of synchronicity that occurs. So these are all the things that can really kind of tell us how perception of time develops. Next, let's talk about numerical ability development. So what we know is that there are certain brain areas that are involved with numbers, particularly in the intraparietal sulcus. And then, so because when there are specific neurons that are in this area that basically respond to a particular number of objects when it's displayed. Okay, so which means that there are neurons that specifically respond to 7 objects. There are specific neurons that will respond to like 5 objects, and so forth. Okay. Now, the numerical ability really has to do with um, that all sets of n objects have like something in common. Okay, and something I do, so for example, understanding the numerical equality implies recognizing there are three dogs, three pencils, three balls, and three, just basically things that happen in three. Okay, share like the property of threeness, basically. Okay, now when it comes to the discrimination along temporal durations, um, infants' discrimination between numerical sets also depends on the ratio of numbers and the number of the entities in them. Okay, so what they did is that they found out that infants at a very young age, they were able to discriminate 3-to-1 ratio, but not 2-to-1 ratio. And as the infants grow older and older, they are become better at discriminating this smaller amount of number at 2-to-1 ratio. Now, around 4 to 5 months, the infants they can start to actually do some simple arithmetic. Okay, so this is the actual experiment that they did. Okay, so they try to kind of like imitate a sequence of event. 1 plus 1, does it equal to 1 or does it equal to 2? Okay, so they put the object place in place, and at 2 you see that the screen comes up, and then the third thing is that they add a second object, and then they leave the hand, that the hand leaves empty, and then this is one of the two possible outcomes. They drop the screen and then they reveal there are two objects, so this is one outcome, or they drop the screen and there's only one object that comes. So basically they want to see which one does the infant dishabituate to. Okay, now so the one that they dishabituate to means that there is something that's more unexpected. Okay, so the infants they would dishabituate to this. Okay, which means that they were able to do some sort of simple arithmetic in their head that they were expecting that there should be two of these fox dolls that are within here, not just one in here. Okay, so you can see that inside the infant's head, they were already able to do some sort of arithmetic. Now let's talk about the cultural differences when it comes to the counting abilities. And so this is really comparing not the two nations, but this is really comparing the two languages. Okay, so what we can see is that the rate of which they do is kind of really affected by the number system. So what we know is that Chinese counts like after 10, then the issue is that we don't say 11, we don't say 12, we say it as 10-1, 10-2, 10-3, 10-4, and very similar to like when we say 21, 23, or 33, 34, 35, and stuff like that. So the problem is this awkwardness in English that has to go from 11 to 19, and this really is what trips up a lot of the children whose main language is English. Okay, and I'm sure when you guys were learning the numbers in English, you probably thought that the numbers from 11 to 19 was really screwed up as well. Okay, because that was certainly the case when I was learning English. I was thinking that that's stupid. Okay, but it is what it is. I mean, I didn't invent the language. If I invented the language, I would have also say 10-1, 10-2, 10-3. Anyway, so you can see that this is what contributes to the Chinese children's greater counting proficiency when it comes to being much better at the counting abilities. Now I'm going to switch gears and talk about intelligence and intelligence testing and also intelligence development. Okay, so the development of the intelligence test actually happened in the French education that becomes widely available in the 1900s, I think 1904 to be exact. And so the problem with that, because France has become like universal when it comes to public education for the children, and it became very apparent that some of these children they're not learning very well. So therefore, they kind of wanted to have something to they want to have like a separation of class in terms of the students that would need special education. Okay, so they can kind of unify the curriculum in terms of difficulty. And then, so then the problem, of course, it becomes how to identify these children that are kind of like lagging behind and have intelligence issues. So what happened is that the French psychologist Alfred Binet was commissioned to develop an intelligence test. And Binet is a person who has really studied intelligence for a long time, even before that. So Benet's theory about intelligence is basically something that is different from the prevailing wisdom of his time. And so basically, he believed that the key components of intelligence were high level abilities, such as like problem solving, reasoning, and judgment. So he really thought that it's we should intelligence tests should like address these abilities directly. Okay, so he came up with his own intelligence test. The first version is the Binet-Simon intelligence test. And then, so the children, they were asked to interpret like words and solve puzzles and define the words and then have kind of sequence of cartoons and do block designs and all this kind of stuff. So these stuff are the ones that Benet really kind of believe that are the central ideas of what intelligence really is tapping into. So you can see that the way that he developed his intelligence test is really based on these abilities that he really thought that are very central to everyday as well as learning abilities and then and so forth. Now, let me kind of tell you a little bit about what intelligence is, okay? So intelligence is very difficult to define, and if you ask five different psychologists who study intelligence, I'm sure you'll get five different, completely different uh, definitions. Okay, so part of this difficulty is that intelligence can be legitimately be described as three levels of analysis, as one thing, and as a few things, and as many things. So what really is intelligence? Okay, so intelligence, as I said to you guys, it really could be defined as a single trait. So the people who kind of believe this is that this is the amount of G, okay, with general intelligence. So the G actually influences our abilities to think and learn all intellectual tasks. Okay, now the second view is that the intelligence has a few basic properties, and then this really kind of tells us the difference between fluid intelligence and crystallized intelligence. So what is fluid intelligence? This is the ability to think on the spot or solve novel problems. So things like the problem solving abilities and reason out of stuff, that is more like fluid intelligence. And crystallized intelligence, on the other hand, is more like factual knowledge about the world. So these are the things that people would say is more like semantic memory. If you later on, if you take cognitive neuroscience, it will go into a lot more of these. All right. Now the third view is that they think intelligence as a numerous cognitive processes. Okay. Now, I'm not going to go into like all of these processes, but then But what I want to bring out is there is like a proposed resolution when it comes to what intelligence actually is. So in this um, proposition, basically propose a grand integration, and this is like a three-stratum theory of intelligence. And this is what you're seeing. So on the top level, what you're seeing is the general G, okay? And then within that, you see things like fluid intelligence, crystallized intelligence, general memory and learning, broad visual perception, blah, 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 all that stuff. So these are the more individualized facets, okay, that kind of comprise of this entire general intelligence. And within each category, then you have each of the time of the kind of task that, so for instance, the fluid intelligence really, the way that you will want to assess that is using sequential reasoning, induction, and quantitative reasoning. And the one that you want to assess, let's say the crystallized intelligence, you will want to use things like printed language or language definition or vocabulary knowledge. Okay, so these are things that are still being adapted today into today's version of the intelligence test. Now, what's in the content of the intelligence test? Okay, you can see that the intelligence is really reflected in many different abilities at different ages. And of course, as the children develop, the amount of the items they're able to accomplish should also increase. Okay, so for instance, a 6-year-old, they should accomplish many more items than a 2-year-old. Okay, especially that the way that these items work is that they range from very easy to very difficult. Okay, now there is typically a starting point. Okay, so because the items range from very easy to very difficult, and then there is a typical starting point of, let's say, item number 23. This is where a typical 10-year-old should start testing. Now, if a typical, because this is the place where typically 50% of the 10-year-old can answer correctly and 50% cannot. And if the person that you're testing is smart, then they should be able to advance more and more items, okay? And then the people, if unfortunately that you're testing is not very smart, then you have to go back. So you have to go from item number 33 to item number 32, 31, 30, and things like that to kind of really get an idea where their intelligence is. Okay. So now the one of the most widely used intelligence testing for children 6 years and older is this the Wechsler scale, WISC. Okay, so they call it the Wechsler Intelligence Scale for Children. Okay, so I'm just going to call it WISC because that's what we call. Now, there are many versions that was published before. The one that I'm most familiar with is actually WISC 4, but now they actually updated WISC 5, the fifth version. Okay, so now let's take a look at some of the typical intelligence test when it comes to the verbal comprehension items. Okay, so there you can ask them something like, "What is helicopter?" And then things like, "What are the similarities between mountain and rivers alike?" Okay, so these are these are to kind of test your crystallized intelligence. Okay, so this is a way to really to test what are the similarities and can you draw parallels and then things like that. Okay, so the next thing, for a typical visual spatial processing items, basically what they would say is like, can you put the 9 blocks together so they look exactly like this picture? And then the testee's job is to really basically trying to put together all of these blocks and then present them to make them look like this, and present them to the not experimenter, but then the test administrator. Okay. Now let's take a look at a typical fluid reasoning item. So for instance, this is the picture concepts. So the actual prompt is actually, well, pick an object from each pair to make a group of objects that go together. Okay, so you can get an idea how a person may pick. Well, the correct answer is this object goes with this object goes with this object, because they are all tools, right? But you can also now some of the children, they might also pick this one with this one with this one, because these are all living things. Okay, so it really depends on what goes together with what. But you can see that the one with the living thing is like one is animal, one is plants, right? So your reasoning, you have to kind of tell the the test administrator what is the reason why you picked that. Okay, but usually there is a correct answer that the test administrator is looking for. Now let's talk about the working memory items. So there are two types of memory tasks in the WISC 5. Okay, there is the digit span, and so this basically, you tell the people repeat the following number in the order when I'm finished, and then when you also say it in the backwards order. Okay, so let's say if the test administrator says 1, 2, 3, 4, 5, you're supposed to tell them 5, 4, 3, 2, 1. Things like that. Of course, it's not going to be that easy, but then so this really kind of tests your working memory. Now the letter number sequencing we have talked about, and this is basically we repeat the number from the smallest to the biggest, and then repeat the letters from the earliest to the latest in the alphabet. So you're supposed to reorganize them in two columns, right? So let's say in this example that you were seeing is 4D to G7, then what you're supposed to tell the test taker, if to the test administrator, if you're the test taker, then you have to tell them, okay, so the numbers goes first, right? So you have to tell them 247DG, okay? So that would be the correct answer, okay? Now, the last one, when it comes to the processing speed items, okay, so the processing speed is the last of the ones that they go under. So they would say that, so the coding would be something like under each of the square, put a plus under the square. So basically this is a way to kind of tell people to kind of ask the test taker which one is how fast you can do something as fast as possible. Okay, because we have said this idea with the processing speed that when two people can do exactly the same task as well, they can both come up with the correct answer. How do you determine who is smarter? Well, the person who can do it in the smaller amount of time is the smarter one. Okay, so that is the whole idea of the processing speed. The quicker you can do something that is relatively easy, the greater speed, and therefore the greater amount of the intelligence you have when it comes to solving problems. Okay, now the intelligence tests such as the WISC and the Stanford Binet, they really provide a quantitative measure of the intelligence relative to other people. So this is what IQ is. This is what intelligence quotient is. Basically, this is how you are compared to the people who are in the same age as you. Okay, so now understanding how the IQ really is calculated, we need to understand a little bit about statistics and how the normal distribution works. Okay, so The normal distribution is something that when you pick out like a very large group of people, you'll see a normal curve like this. And you might know this as a normal distribution. You might know this as a bell curve. You might know this as a Gaussian curve. So it really doesn't matter with the nomenclature. It's just what it means. Okay. So now, the mean, the numerical average is going to be in the middle, okay? So as you guys, if you learn statistics, you know that this has a z-score of 0, okay? And percentile-wise, if you score at the mean for the population, that means you're at 50th percentile, okay? So that means about half of the people in the world are smarter than you and half of the people in the world are dumber than you. Now, when you go from one standard deviation away from the mean, okay, let's say if you score a one standard deviation that is higher than the mean, then you are at 84 around 84 percentile. Okay, so that means that there are only about roughly 16% of people who are smarter than you, and then you are about 84% smarter than the rest of the world. Okay, now when you are two standard deviation away from the mean, okay, so let's say, and then you have an IQ score of 130, okay? 130, then you are somewhere around 95, I think 97 percentile when it comes to the IQ. That means there's a little bit more than 2% of the people in the world that are smarter than you. So which means that you're very smart. You are smarter than 97% of the people in the world. Okay, now when you go 3 standard deviation away from the mean, then you are a very smart person. Okay, so you will have an IQ of 145, and then you are scoring in the 99th percentile. Okay, actually 99 point something percentile. Okay, that means only about 0.13% of the people who are smarter than you. Okay, now how high does the whisk with the Stanford Binet go up to? The whisk really go up to about 155. Okay, if you get everything on the thing on the scale correct, and you did it as fast as you can, I think the highest score that you can go is about 155. Okay, so it really does have a limit of testing like geniuses. So if like a person who is a member of Mensa, which is like a cooperation association that has not cooperation, sorry, with which is like an association that has some of the smartest people with IQ greater than 140, and then you're probably thinking, well, how do they test with the people who has like IQ of 160 or 170 and stuff like that? Well, they have special intelligence tests for that. Okay. So what is IQ score actually good for? So it turns out that it's a very strong predictor for the things that we care about, such as academia, economy, and occupational successes. So you can see that on the y-axis, this is the amount of the dollars that they earned on a weekly basis, and on the x-axis, we are seeing people who completed high school with 2-year college or 4-year college. And the color code that we're seeing is that this is the IQ quintile, okay? So top 20%, bottom 20%, and everything that is in between. So basically what you can see that when you look at this thing, you can see that the IQ really do matter. Okay, so the people who are on top of this quintile, they really earn a lot money even compared to people who completed college. Okay, so when you compare the purple here and the blue here, they earn about $100 more per week. Okay, and then of course, and over here you can also see that another factor that actually predicted economic success is also the amount of the schooling that you get. Now, I want to bring out that the amount of schooling is also going to affect your weekly wages because the kind of job that would allow you to earn also matters. Okay. Now, what are some of the other things that can also be predictors of success? Because you are probably thinking that, oh my God, okay, I remember I had a IQ test that did not go so well, and what can I do to mask myself to really make sure that I still have a good outcome in my life? Well, the first one is self-discipline. Okay, so this is the ability to inhibit actions, follow rules, and avoid compulsive behaviors. And so these are the things that are really a good it's more predictive of changes in report cards and things like that than the IQ scores. All right, so and another one that we can know is emotional intelligence. This is the ability to deal with others socially, that you don't piss off people, that you don't make enemies in your life. So of course, this can also make you go a long way, and especially when we know that life will always have problems that present themselves even when you don't ask for them. And this is the time for you to really ask for help of the people that you have known before, so you can kind of get their help. And this is also um, forces that can really help you when to go far in life as well. So IQ is not everything, I want to say, but it's also these other aspects such as self-discipline as well as emotional intelligence that can really help you have a better life as well. Now let's take a look at the long debated question about nature versus virtue. Okay, and what does it do to the actual aspect when it comes to the intelligence development? So it turns out that genes are one of the most important aspect when it comes to development of the intelligence. So as we know that the genome can really substantially influence intelligence, and this genetic influence varies greatly with age, but in general, when we look at the chart on the right, okay, uh, on the x-axis, what we have is the age. Okay, on the y-axis, what we have is the variance accounted for. And you can see that the variance that is accounted for, and when it comes to the intelligence development, the genetic aspect of it increases when it comes to the development, and then the environmental contribution really is decreased more and more. So that means that if your mom and dad are smart, chances are when you get to adulthood, you are really going to be smart as well. And then the environment can really only take a part of that. Okay, and now it might take a greater part of that in the beginning, but at the end, when you become adulthood, basically uh, it's all genetics. Okay. Now let's talk about the influence of schooling. Now this is something that you probably already know what your common sense tell you, and it's that going to school makes children smarter. So let's just take a look at their standardized scores as a function of the grades that they are getting. All right, so you can see that the x-axis is basically telling you the age in months. Okay, and the y-axis is the score that they actually get, and the color coded is the grade that they are. You can see that when it comes to both verbal oddities, as well as word arithmetic problem solving abilities, the more schooling that they got, the better their grades also get. Okay, so this is something that I'm sure you already know what you have already suspected. Now let's talk about the effect of socioeconomic status on IQ. So here what we're seeing is the reading and math scores upon entering kindergarten by socioeconomic status. And you can see that the children from family with lower incomes and education, they kind of lag behind the peers when that are more affluent and educated backgrounds. So what we are seeing here is that the x-axis we're seeing is the socioeconomic status quintile, okay? So this is the highest 20%, this is the lowest 20%, and then the y-axis what we're seeing is the average percentile rankings. And you can see that in both math score as well as reading scores, the ones that are coming from a more affluent um, a family, the children that are entering this, they are usually also higher. But of course, as we said before, the IQ is also like a very strong predictor of um, economic status and also economic success, right? So chances are the people who are rich are also going to have higher IQ, which means that there is also a good uh, chances that the parents of these children, not only that they are uh, richer, but they're also smarter. You see how that kind of like we don't right now we don't know if this is the chicken or an egg issue. So you don't know if it's like the actual having resources and because they're rich that are making the children becoming having higher IQ, whereas the fact that these children's parents they are smarter and therefore they're richer and those are the genetic traits that are being passed on as high IQ. Okay. Okay, what is another thing that can influence the children's IQ, and that is father's education. So here what we're seeing on the y-axis is the percentage of math items correct, and on the x-axis is the status of father's occupation percentile. So 100 would mean that this is a very desirable job in terms of socioeconomic status, and 0 means this is something that nobody wants to do, okay? And you can see a very strong trend when it comes to Canada and especially US is that the father's education is really very tightly correlated with the percent that is correct on the math item. Not so much in Japan, okay? And so this really kind of tells us the importance of education when it comes to like the curriculum, because we all know that well, Canada is better, but we know that U.S. like mathematical education sucks compared to any other Asian countries. Okay, so basically, I'm not like trash talking U.S. education before universities, but then it really is a lot of room for development and further improvement for the U.S. educational system, especially the public education systems compared to Asian countries like China or Japan or Korea. Okay. Okay, now these are the risk factors that are related to IQ scores. Okay, so on the left, these are the 10 items that are risk factors. So I'm going to go through every one of them. So one is head of household unemployed or working in a low status job. You saw it from the previous slide, so I'm not going to go over that much. Second one is the mother did not complete high school, which makes sense because she would not be able to teach or provide any kind of insightful education to the kids. And the third one is at least 4 children in the family, which makes sense. That means that the parents won't have that much time to devote themselves to individual children. And fourth one, no father was stepfather at home, which makes sense because single parents don't have that much time. they have to provide economically for the children, and then they won't have that much time to devote themselves to the children. Okay. Fifth one, African American family. Something we did not say, but there is a slight racial effect when it comes to the ethnicity and IQ. Okay, sixth one, the a large number of stressful life events in the past few years, and something we have not talked about a lot, and that is juvenile stress is actually very detrimental to the development of the nervous system. And of course, this is also going to be a very negative outcome when it comes to development of the IQ. Okay. Number seven, rigidity of parents' belief about child development. Of course, if you don't believe that child can develop in a proper way, you don't want to devote themselves at all to actually uh, uh, to have children develop the way that they should. Okay. Number eight and nine is all like maternal anxiety and mental health problems. Of course, these are all going to be issues. And also number 10. So mother really plays a very important role when it comes to child development. Now let's take a look at the number of the risk factors. When there are zero, you can see that the IQ is relatively high, but that as the number of the risk factors goes on, we can see a general decrease in the trend when it comes to the IQ. So which means that the more number of risk factors there are when it comes to the IQ scores, the more likely this is going to be a detriment to the IQ score for the kids. So for next class, let's talk about language and language development. So we'll first talk about the very basics of language and the symbols, and then we can talk about some of the language development when it comes to things that you have heard before, like critical period, and also the aspects of that. Now, when the unfortunate part is that because your textbook is actually uh, an English textbook, and then doesn't really talk that much when it comes to the development of language when it comes to other languages. I mean, it kind of very specifically talked about learning a second language when it comes to the critical period, but it doesn't really talk that much about a completely different culture, such as how do babies learn Chinese or other languages. But this is something that I think I may need to look on that. But then I will definitely also kind of briefly talk about that. Okay, so I will see you guys in next lecture.